Section 13.2, line integrals, video 2. So how do we set up a line integral? In a word, parametrically. Get ready for a bunch of parametric equations. In other words, when we define a curve in the xy plane, we can define its x-coordinate as some function of t, which could be time, but it doesn't have to be. And we can define the y-coordinate as another function of t. Typically, those functions are called x of t and y of t for the x and y coordinates. And then we define it over an interval of values, we'll say from a to b, for the parameter t. And so when you put in the least value of the interval a into your function, then you get the coordinates for the beginning of the path. So x of a comma y of a would be the beginning of the path of the curve. And then when we put in the final value in the interval b, we get the coordinates for the end point of the path or the curve, x of b comma y of b. And then there's an orientation from the beginning to the end. So it's pretty common to see arrows indicating the direction of a path from the least value of the parameter to the greatest value of the parameter. So now what? Well, because we're going to do everything in terms of the parameter, we want everything in terms of t. So we're going to turn this into a single integral from a to b, and eventually it's going to be dt. Now, how do we get everything in terms of t? Well, the first thing we have to do is go inside the function and replace every x with the function x of t, and replace every y with the function y of t. That will change every x and every y to something in terms of t. But what about the differential, the arc length differential? Now, in theory, you've already seen this back in section, I believe it was 9.2, where you found that the integral for an arc length was the integral of the square root of the sum of the squares of the derivative of the x function and the derivative of the y function, and that gave you arc length from a to b. Well, we can kind of use the same analogy here to define, well, actually, let's just do this. This was arc length, right? So we take the derivative, well, this would be a constant, so let's call this an arc length function. We'll say s of, and I have to bring in another variable. We'll say s of v from a to v would give you the arc length over a certain interval. Well, if you take the derivative, actually, let's change this. I'll change it s of t from a to t, and now we got to change the variable of integration, but it's a dummy variable anyway. We can call it anything. We'll call it u. And then by the fundamental theorem of calculus, we can take the derivative of both sides. So the derivative of the arc length function would be the integrand evaluated at the upper limit. Square root of x prime of t squared plus y prime of t squared. If you're going, wait, what? I would go back and review arc length back in 9.2, but at this stage in calculus, I have to take some things for granted. So what does that get us here? Well, this is really ds dt, and we can replace each derivative in here. Actually, we don't have to. We can just leave them as x prime t squared plus y prime t squared. And then in a very hand-wavy move, if we multiply both sides by dt, we get that ds equals that. So in other words, we can replace the ds with something that is explicitly in terms of the parameter t. So completing the integral here, we can evaluate the line integral by replacing each x with its parametrically defined function, each y with its parametrically defined function, and replacing the ds with the square root of the sum of the squares of the derivatives of the parametric functions, dt. I like long prepositional phrases like that. The square root of the sum of the squares of the derivatives of the parametric functions. It's really just has to do with the Pythagorean theorem, but let's not go that far back. All right, so now we have this technique for evaluating a line integral, but it presents one problem. If we're given a curve and it's not defined parametrically, how can we define it parametrically? Well, we'll take a look at a few examples in subsequent videos.